All right, this is going to be the bulk of your next assessment, which is lesson 6-5 on solving exponential equations. So let's go ahead and get started. Let's take the following. Remember that if we have 2 squared, it's going to be equal to 4, right? So we can actually back this guy out. Remember that when we have the same base there, so for example, if I said 2 squared is equal to 2 to the x, right? What x would be equal to, of course, would be 2. What's actually replacing it. So I want you guys just to consider that as we start, all right? Some of these problems should be pretty straightforward. And it's going to actually show you the need for something else that we work with. It's called a logarithm, which we'll do in the future. But take these 2 problems here. We have 4 to the x plus 3 equal to 4 to the 9th, okay? In this case, because my bases are the same, I can actually take and equate these exponential, these portions that are in the exponent, and then create in my own equation to solve. Now that's actually very straightforward for you guys, right? I hope. So and this is the case that 9 minus 3x is going to be equal to 6, right? Because 6 plus 3 would be 9, making those 2 equivalent statements, all right? So should be pretty straightforward using the same sort of principle. How about we do the following? We have 2 is equal to 2 to the 3x minus 2, okay? Now remember what this means. It means right here, technically what we have is 1, right? 2 to the first power is just going to be 2. So what we can actually rewrite this as is 1, since the bases now are the same, both 2's, that 1 is equal to the other exponent, 3x minus 2. And this should be actually pretty straightforward for us to solve, right? 3 is equal to 3x, therefore x is equal to 1. Right? So these are just effectively pretty straightforward linear equations. Just remembering what this rule is, right? So 8 to the 3x minus 4 is equal to 8 to the 2x plus 1. So we have these guys right here, right? These are going to be equivalents. So we have 3x minus 4 is going to be equal to 2x plus 1, okay? So minus 2x, right? X minus 4 is equal to 1 plus 4 plus 4. And these, again, very straightforward linear equations that we have. One, sometimes just 2-step, but rather straightforward. Okay, let's throw you a curve here. Let's take 6. You know what, let's do it this way. Let's actually take 5 to the x is equal to 125. Now, other ways to do this, right? What we need to figure out is what 125 is with a base of 5, okay? So what we need to figure out here, and in some cases, you know, you guys are going to have to work this out arithmetically without a calculator, and that's just the way it's going to be, okay? 5 times something, or a base of 5 times itself however many times is what we got to figure out. So this is when you guys just start doing this on your own. 5 times 5 is 25, right? Times 5 more is 125. So that's 5 multiplied times itself 3 times. So in other words, 5 to the 3rd, right? Leaving us with that x is going to be equal to plainly 3. And I think you guys may see where this guy is going, okay? How about the following? So we have 4 to the x is raised, or so is equal to 2 raised to the, x minus 3, not just 2x, but x minus 3. Okay. So, looking back on this, we need to make these bases the same. And how do we do that? Well, we do that as follows. This is going to have a base of 2, right? Well, 2 to what power? It's going to be 2 to the 2, right? Now, 2 to the 2, that's going to be my 4, and that's still raised to the x. And that's equal to 2 raised to the x minus 3, right? But now we actually have to figure out what happens when we have a power raised to a power, right? What that means is we have 2 raised to the to the 2 to the 2 raised to the x. So remember, that means that we're going to multiply here 2 times the x. Remember, a power times a power, right? If we had 2 squared, right? That's going to be 2 to the 4th, okay? So now we have matching bases, okay? And that's going to give me 2x is equal to x minus 3. Subtract my x from both sides. And x is going to be equal to negative 3. All right. Let's keep going. How about 4 raised to the 2x equaling 8 raised to the x minus 2. Now we have to change both of these bases, okay? Here's our problem. Let's get 2 bases here that are going to be the same. So I'm looking at this 8. And this is the guy that really is going to force my hand. This has got to be a base of 2. Now, can I write 4 as a base of 2? 8 as a base of 2 is going to be 2 to the 3rd. And 4 at the base of 2. I'm going to actually write this guy in blue here so we can kind of separate him a little bit more logically. 4 with a base of 2 is, of course, going to be 2 squared, okay? Now, remaining portions outside of those bases, right? So we can see that direct relationship, right? The base of 4, right, being 2 squared, and the base of 8 being 2 to the 3rd. Now that we have the same base, we have to rewrite these guys and clear out those parentheses in a way that we can effectively have these exponents, same basis where we can make these exponential portions equal to each other to solve for x. So 2 raised to the 2x, right, is going to be 2 to the 4x. And on the other side, 2 to the 3rd to the x minus 3 is going to still be a base of 2, but I have to distribute 3x minus 9. Okay? I'm sorry, gentlemen. I miswrote something here. I'm looking at this thing and I'm going, wait, why am I getting the wrong thing here? You don't remember? There was this. This should be minus 2, making this minus 2. My apologies. This should be a minus 6. I was trying to figure out why I got a minus 9 there because I'm looking at this. I'm like, I got the wrong answer here. So here we are. My apologies. Now we're all straightened out. Okay? Now we just make these two things equal to each other. So it's just a little transposition error, which is a critical mistake. One of the reasons we really need to make sure that we take our time and write out the correct things procedurally. Yeah, there we go. So we're going to subtract the 3x from both sides and have our x that's equal to negative 6. It's a difficult thing of me doing these in, on these video streams rather than in class, right? Okay, let's keep moving. Let's actually really throw some curves here. So we have to the 1/6, right? Raised to the x, and we have 2/16. Okay, so we need to change our bases here. I think it's actually the 2/16 that's going to give it away. So remember, that we have actually done this one before, right? 6 times 6, which is 36, times 6 more. And I got the idea here from this 1/6. That this is going to be 6 times 6 to the 36, and 6 times 36, which is going to give me my 2/16. So I have this guy as 6, right, to the 3rd power. And then I now have my base of 6 here. 6, making it 1/6 is to the negative 1, and that's still to the x, okay? And I need to make my bases match, right, which they do. But then now I've got to take my 6 to the negative 1, and I have 6 to the negative x now, which is equal to 6 to the 3rd. Or in other words, negative x is equal to 3, so x is equal to negative 3. Okay? So dealing with converting these fractions into a negative exponent. So I have 5 raised to the x plus 3, okay, and that's going to be equal to 1/25. All right, well, again, I think we're all set over on the left side of the equation. The issue over here is, what is this guy going to be, right? So this guy winds up being a base of 5. And remember, how do we make 5 to the 5 squared is going to be 25, so 1 over 25 is going to be in the negative exponent. So this guy's going to be to the negative 2, okay? Remember that is just, again, how we're going to convert these things. If it was just equal to 25, we'd make this 5 squared. But since it's 1/25, it's 5 to the negative 2. And now we're actually kind of in the home stretch. Again, these guys are going to be equal to each other, right? Because of those exponent portions. So the same bases. Subtract 3 from both sides. And x is going to be equal to -5. Okay, last one of these before we do, actually until I cut you guys loose to do some work. This is going to be 1/3 raised to the x minus 1 equal to 27. So I have to convert 2 of these things. Okay, now remember, this guy right here, and this is what's going to give it away, is that denominator. We want to create everything with a base of 3. So here we are. Here's my base of 3. 3 to what power? That's to the 3rd power, right? 3 times 3 is 9, times 3 is 27. So 3 multiplied times itself 3 times. And then we have the 1/3 here, okay? So again, this is going to be 3 to the -1, right? It's going to be 1/3. And we make that reciprocal. It's still to the x minus 1. And so then I'm going to distribute, right? I'm going to take this guy, and I'm multiplying times raising the power to the power. So I have my base of 3. It's -x minus -1, which is +1, is equal to 3 to the 3rd. And of course, I'm just going to take the exponent portion. So -x plus 1 is equal to 3. Minus 1 minus 1, so I have -x is equal to 2, meaning that x is equal to -2. All right, so that's all I've got for you guys for today. Again, this is going to make up a good chunk of what's going to be on your test. Probably 4 of the 10 problems that you're going to have tomorrow. So if you have any questions, please reach out to me via email. Good luck.